these two rectangles, a similarity statement is going to show which sides correspond to which sides. It's really useful. So let's say the first triangle or rectangle, we're going to say LMNO, and we're going to say it's similar, like a little, okay? It's similar to this next one, and I want spots that kind of match up from the big one to little one. So I would say QRST. And it won't, a lot of times, you know, if you're getting organized using alphabetical order, a lot of times it will be, but it doesn't have to be. Now here's why this is useful. Take for example this side, ON. ON is those two, and it's the same thing as ST, which is the last two there. It always matches up. So when you're talking about corresponding sides, you can use your statement to identify your sides that are corresponding. Because these rectangles, while they're situated the same, there could have been another rectangle like this that's similar, let's say, and it's not oriented the same, right? Then you could use your similarity statement to make sure that you're talking about the same part. Because if it was similar, right, that side might match up with those, which would be on the side instead of the bottom, right? You seen how you could use that? And where that's really going to come into play is on like the second one. But before we move on, I need someone to tell me if these figures are similar, and if so, how do they know? James?
It's similar because 2 times 2 is 4 and 6 times 2 is 12.
So you're saying you can multiply 2 from small to big and it works. Okay. So yes, those are similar. Or divide by 2 this direction. Yep. Great. So let's look at number 2 from your notes. I'm just going to get it into my... So what do you notice about these two pentagons?
I think they're similar.
So I'm more interested, so you're thinking they're similar, but I'm more interested in their similarity statement right now. Now, you can't just go by how things look, right? Because I don't know if you noticed, when I drew my stuff for that last problem with the shadow, was it to scale?
No.
No, it's a visual representation, so it won't always be perfect, even though I like it to be perfect. But Mikey, if I am going to call my first pentagon E, F, G, H, I, how would I, to keep corresponding parts with parts, how would I write the letters for my other pentagon?
U, V, W, U, U, V, X, W.
U, V, W, X, Y?
Yeah, that's what I said.
Okay, so let's check it out. You're saying, let's test it out. Way easy to test out. So, let's say here's 2. That's GH. That's kind of like the side of it, right?
That's XY.
You think that's XY?
Yeah.
It's WX.
So let's test it out. If you think those are the same,
I'm not WX. I'm not,
here's
I
HG,
think it's 10. No,
here's XY. Those don't match up.
That's not what I think.
So what do you think it is?
WX, where it says 10.
You think it's WX?
Where it says 10 seconds.
Yeah, so notice in the statement, look where GH is.
It matches up.
It matches up with WX. And those are the corresponding
And that
sides.
makes it proportional.
So do you see how those statements can keep us straight? Because 2 figures can be flipped, they can be turned, right? Orientation doesn't change similarity. It just changes how it looks, yeah. So if you're ever confused with that, use the statement. The statement, if it's given to you, will tell you which parts correspond to which parts. Yeah. So, let's see here. Are these similar? It'd be nice to have more information, but from the information we have, are they similar?
They don't look similar.
They don't look similar, but from the information we have,
Yes,
Yeah.
they are.
yeah, I would take either one depending on justification. There is a scale here of times 5, but I would really like to know what this and this and this are, just to make sure that it appears as though the intent is to have them, yes, be similar. Okay, let's jump to number 4 in your notes. How about number 3? While I'm getting this ready, is number 3, are those similar figures?
No.
They are?
Yeah. They're not.
Oh, we've got some discourse.
Yeah, they are. Oh, that's true. 3 times 3 is 6.
So for number 3, they do have right angles.
They're not, because
But if they are similar, they'll have a factor that's the same on number 3, James. Do they have a factor that holds true? No. All right, looking at number 4, let's look at this statement again. I'm going to call my first one XYZ. Oops.
Yes, those
And
are-
I want tangent to tell me what XYZ would have to be similar to. Tanya? Hey, Tanya. Can I just not hear you? He's muted, right? Tanyan. Oh, he's trying to talk now. You're muted, bud.
Oh, yeah, we're good.
This is going to make for an exciting YouTube video.
Wait, is it recording right
He's still. Isaac, can you tell me what to send XYZ similar
I'm
to?
pretty sure he's talking, he's just muted, because the yellow boxes are
Well,
on.
if you turn around XYZ, it'll look like ABC except smaller.
Yeah. So let's test that out. Let's test the slanty, the hypotenuse. I guess we don't know if it's a right triangle, but it looks like it. So XZ, that's the first and third part. So the slanty on the larger should be AC. Is that true? Yeah. Do you see how the statement matches the corresponding parts? And then just for fun, are these similar?
Yeah.
Is 2 to 10 the same thing as 5 to 25?
Yes.
Yeah. They are similar. Nice. So number 6 on your notes is asking what must X be for these two things to be similar. So there's a couple ways to go about this, okay? I'm going to continue to show you how to use cross products because that's the new thing, but I'm also going to ask for other ways. I like to set up a proportion where X corresponds to 12 and 18 corresponds to 72, right? Because 12 should be the same ratio bigger from X than 18 should be to 72. Would you agree?
Yeah.
So I probably wouldn't solve this with cross products, but I'm going to show you. There's my 72X. 180 plus 36. Is that 216? I don't have a calculator. Anybody confirm that for me? 180 plus 36, 216. Okay. And then I'm going to divide both sides by 72. And that's going to give me an X value of 3 centimeters. All right. Now, realistically, the way I personally would do this is I know this is 1/4, and I would do times 3 times 3. That's what I would do.
Wait, I have not.
But there's several ways. Mikey, thanks for raising your hand. What's up?
I get what you're saying,
Yeah.
but I feel like there's such a more simple way to do it. You just flip you can tell from just looking at it how if these shapes are proportional, what they need to look like. So you flip it and then you realize 18 and 72 are corresponding and you do 72 divided by 18, that equals 4, and then you do 12 divided by 4, and then you have your X.
Yeah, that's what I did here.
He did that, it just made it look more confusing.
Yeah.
No, I'm just saying things are proportional, right? A proportionality statement. If they're similar figures, they have to be proportional. It's the same thing. All right, let's take a look at number 7 next, please. From your notes. It's got that building. Very fancy looking building. And we want to know what X would need for these things to be similar. So someone help me build a proportion. You don't have to, but I like to start with X at the top. So John, help me build this out. I always start with X. You don't have to. Any proportion works. But what does X correspond to?
10,
X is to 10 as?
15 on top and 75 on bottom.
So you're saying this left to right is the same thing as right to left? Want to make any changes? Left to right. So this one's left to right.
Yeah.
So my other ratio has to be
15 to 75.
left to right.
Oh, 75.
Yeah.
Isn't that what he said though?
Now we had 15 to 75, and it'll make a difference, right? Because if this is big to small, this one has to be big to small, right? Are you seeing that?
Uh-huh.
Cool. Good mistake. So then from here, there's multiple ways to do it. I'm going to show you the cross product. 15x would equal 750. Divide both sides by 15. and we get 50. Okay, the way I personally probably would do this one is I know that this is 1/5 times 10, a 1 and a 5 times 10 times 10. That's probably how I would do it, but I want to keep showing you that cross product. That's the new way. For number 13, I'm going to ask Lily to help me set up a proportion here. So Lily, I'll start by naming the tree height unknown, and this is going to be kind of like what we did with Steve and the bell, right? So Lily, help me set up a proportion here.
So, you're right down that.
So let's do height of the tree. What does that correspond to?
3 feet.
I just can't hear you.
3 feet.
Okay, well, the height, though, is that the height of the guy?
Oh.
What's the height of the guy?
5.5.
5.5 feet, yep. So, height of tree to height of guy would equal the ratio of what to what? 24 to 3, yeah. That base of the triangle to the base of the triangle. Awesome. Are you guys seeing like this factor here is a harder factor if you're just trying to go from that to that? So this is one that cross products are not a bad idea. So 24 times 5.5. Let's do 24 times 5 is 120 plus the 12 for the half. 132, is that what you guys got?
Yeah.
Divide by 3.
44.
And I get x equals 44 feet. So here's another way I would go about this one. Let me get this so that people in class can see it. The way I actually would do this myself is I'd recognize this as an 8-to-1 ratio and multiply both things by 5.5. That's what I would do. Number flexibility, right? Have you heard me talk about that? That flexibility to use different things at different times where it's going to be easier and more helpful. So this next part is not on your notes. It's on the go formative, but I just want us to watch. And this deals with the same idea, scaled copies. So if you like go to a copy machine and you like click enlarge, you get the same copy, just bigger, right? Or this is a lot like the pinch zoom we've talked about on your phone, where you make things bigger or smaller. So what I would suggest when you get a problem like this is draw a picture. Okay, right triangle. So you're going to take a right triangle and you're going to make it bigger. Are you guys seeing that? Right triangle and it's getting made bigger. Okay? So the original is a 13 centimeter here and a 7 centimeter here. And your enlarged one is going to have a height of 17.5. Are you guys seeing that this problem is not different?
Yes.
So the base, we don't know. But the base corresponds to 13, and the height corresponds to 7, right? I'm actually not going to solve this. I think you guys know how to solve this at this point. But another question you could be asked with this is, what is the scale factor? Okay? And I always think of the scale factor as the ratio of the fake to the real. Okay, the new one to the old one. That's how it always works. I just like the words fake to real because in any situation, it kind of helps me keep. So, which one's the fake one? The new one or the original one?
The new one.
Yeah. So like this one is my fake. This one is my real. So if I want that ratio, my scale factor would be fake
17.5.
to real, and I could make that like a unit, right? I could divide those both by 7. So just know whenever you see something like scale factor, what's the scale? It's always the ratio of the fake thing to the real thing. That'll work for all the models, because you might see a lot of things, scale drawings, models. All right, so let's put that to work. On number 10 on the Go formula, there's a scale model, and they give you the scale. And remember, this ratio is the what to what?
Real to fake. Or
Fake to real. And then if they're giving me this 6 inches here, is that the fake or the real?
The fake.
That's the fake. So when I set up my proportion, I know fake to real equals fake to real. And it's going to ensure you get your things in the correct spots in your proportion when you make the proportion. It's always going to be fake to real as your ratio. If you mix up your fake and your real, right, if you flip it, things aren't going to be right. It will not, your ratio will not be true. You will not have equivalent fractions. How would you guys solve this one? I wouldn't do cross products, would you? Someone tell me how they go about this one. James, what would you do?
I would do 6 times 50 equals 50.
Yeah, I would just multiply everything by 6, right? So 300-foot tall building, pretty big building.
30 stories.
Yeah, pretty big building. Guys, that's all we've got. When you work on your formative, make sure that you note in the Canvas document that it's not all the questions. All right? So we'll get cracking. We got some good time for homework. Use the Canvas document to tell you which questions to do on your formative tonight.